Hi guys, here's video 2. Again, I'm Dan Bentley, teacher of Section D, and we're going to look at some highlights from week 7 and just going to take you through a couple questions where we're going to see our laws of exponents and logarithms in action with solving some equations. So, here's most of the laws of exponents and logarithms, and as you notice, all of these are sort of, they have a version as an exponent and a version of a logarithm. So I've got a few others there. Go back and look at them and see if you can see how those other exponential laws look as logarithmic laws. Anyway, these are the ones we're going to be really focusing on in the next couple problems. So here's a great problem. You've got some equation here, and you need to solve for x, but not only do you have to do that, they want the solutions expressed in a certain form, a plus log base 2 of b. So as I'm going through this equation and trying to solve it, I'm keeping that form in mind. That's what I want to get my answer to at the end. Okay? This is a popular IB question, and what I call this is quadratic in disguise. So I often use my exponential laws backwards here. So you see how what I've done here is I've broken off that 2x plus 3 as an exponent and use that exponential law in a sense in reverse. We don't often see it used in reverse, but that would be, as I've written there, 2 to the 2x times 2 to the 3. Okay, so and that would in the next stage be 8, it's 2x, and the same thing happens on the other side. Now, as you notice, I kind of wrote that 2, instead of just saying 2 to the 2x, I wrote it as 2 to the x squared. And I did that because I want you to recognize, as I was mentioning earlier, this could be a quadratic in disguise. So if I just let u equal 2x, look at what I have. Now, this doesn't look too hard to solve. You've seen this hundreds of times before, and it's nicely factorable. So you get the factors, and now you have your two solutions. Okay? But remember, it's not u. We have to back sub now. We're going to go back and replace that u with what it actually was 2 to the x. Okay? And so there's your two solutions. Now you need to think about these solutions. One of them, I don't know if you recognize that, but it is an impossible situation right there. If you don't believe me, take a look at the graph of y equals 2x, and then you'll see why that can never be equal to negative 1/2. So now we're down to this. We're just dealing with 2x equals 2 to the x equals 3 over 4. Now, again, I've got my eye on the finish line, which involves a log base 2. So what I'm going to try and do is log base 2 both sides of this equation. And my exponential log law will throw that x down in front as a constant multiplier. Log base 2 of 2 is 1, so that's just x equals. Now I'm going to use my other log laws, and I'm going to break this up. And as you see, that's the division log law that breaks that up into a difference. And hopefully by now you're feeling pretty good about this because you see that that is just 2. And as you look to what you were trying to do, you now have your A and you now have your B, and you're therefore finished this question. Okay, cool. You can always pause this and go back and look at those steps, so feel free to do that. This next one I've got ready for you here. This is a little more obvious as far as a quadratic in disguise, especially the way it's written. So what I would think about what you might want to replace with u if you want to do a substitution. You don't need to use u. You don't need to substitute. You can just use natural log, but I find sometimes it's easier to picture if you substitute in for a u. So here we have, again, another quadratic. If we put it on one side, equal it to 0, we see that it will factor nicely. And then as I work through this, again, I have my u equals 1/2, u equals 1, but it was actually natural log. It wasn't u. Natural log of x equals 1/2, and natural log of x equals 1. I think some of you right now could just write the answers down, but let's see what happens there. If I've got a natural log, if I want to get rid of that, I can exponentiate both sides. In other words, raise both sides, or use e as my base, and both sides are the exponents. Then I follow through with my laws. E raised to the natural log of x is just x. Check out that law. if you're unfamiliar with that. And that gives me e to the 1/2, which we know as square root of e. And the same on this side, and that's just e. So there is your answers to these two equations. Okay, stay tuned for one more video. Thanks.